So today we're going to look at the other model of the atom. So we looked at Bohr, which was very two-dimensional. So you had your nucleus in the middle, and you have your electrons in fixed rings on the outside. Remember, as you go around, you're going to pair up. So you're going to go around once, and then you're going to pair up until you fill in your electron ring. Here, we're going to look more at it as a cloud. So the quantum model looks at the space around the nucleus, okay, where their electrons are in this cloud. So they're kind of more spread out, not defined in rings. There are energy levels as you go, but they're not defined. Okay, rings are defined. These clouds are more abstract. Okay, so it's a three-dimensional region versus that two-dimensional where it was just flat in the rings. It's three-dimensional. Okay, it's called an atomic orbital, and that's where our electron most likely will be. That's why it means probable. Most likely will be there. And we can use that mathematical equation if we were in higher level sciences to do that from our gallery walk. And that's what people like Schrodinger and the wave model people came up with. So just like in Bohr, as our energy levels increase, the orbital becomes larger. Okay, that's, remember, our electron cloud is giving us the volume of our atom. The orbital becomes larger. Because it becomes larger, our electron spends a lot more time away from the nucleus, and because of that, it takes a lot of energy, and so our energy level increases. So our principal energy levels have sublevels. Okay, so energy level 1 has 1 sublevel, energy level 2 has 2, 3 has 3, and so on and so forth. So on your periodic table, you're going to color your different sections. Okay, so you have an S block, that's your first two columns, along with helium. Okay, helium really should be above beryllium, which is Be, but because it has noble gas characteristics, it's going to be in that category. Then you have your P block, which is over here. Okay, that's the group that has like boron, carbon, sulfur, things like that. This one didn't label. It is the D as in dog, D block. Okay, that's your transition metal group. And then your lanthanides and actinides, excuse me, are your F block. Okay, so on your notes, your S orbitals, they are on every energy level and they can hold 2 electrons. So every S is going to can go to S2 when we start looking at it. So they're spherical shaped. They're called 1s. That big number 1, the big number 2, the big number 3, that's coming from the row or the period that atom is in. So if you were looking at calcium, calcium is in the 4th row, so it would end with 4s, and then is in the second column, so it'd be 2. We're going to need that when we start looking at electron configuration. And again, these are groups 1 and 2 on your periodic table. So the alkali and the alkaline earth metals. Okay, your p orbitals, okay, that's that group over to the right with boron, carbon, sulfur, that whole group. They are going to start on that second energy level. And if you notice, that row, boron starts on level 2 or row 2. They can hold 6 electrons because there's 3 sublevels, so they can hold 6. Each sublevel holds 2 electrons. So if you have 3 sublevels, times 2 is 6. The p orbital is dumbbell shaped. It's called 2p, 3p, again, those big numbers coming from the row. And this is groups 13 through 18 on the periodic table. The d orbital is going to start on that 3rd energy level. Now you're thinking, Miss B, why if it's on row 4? Well, because of the way that electrons like to be stable, the way atoms like to be stable, the outside only wants 8 electrons. That's that valence electrons we talked about before. And so what happens with the D block and the F block is those electrons are going to go into a a previous orbital, a previous ring if we were doing Bohr. Okay, so and we're going to take a look at that when we do electron configuration. I'm going to show you a technique to help you remember. But just know that it's going to be a row previous or an orbital previous to them. D orbitals can hold 10 electrons, and if you count, there are 10 blocks going from 3 to 12. Okay, so that can help you too. They have 5 different shapes. Again, they start on that third row, so 3D, 4D, 5D, and this is our transition metal group, groups 3 through 12 on the periodic table. And then we have our F orbitals. They're going to start on that 4th energy level. They can hold 14 because they have 7 different shapes. Remember, each shape can hold 2 electrons. So 14, and again, if you counted, you would have 14 across. They're called 4F and 5F. And they're those bottom 2 rows, the lanthanides and the actinides, that are pulled out at the bottom of your periodic table. So in summary, each orbital has each level or block has a specific shape, and S has 1, which holds 2 electrons and starts on the 1st energy level. P has 3, it has 6 max electrons, and it starts at energy level 2. D has 5. It has 10 electrons and it starts at 3, and F has 7 shapes holding 14 electrons and starts at level 4. Okay, and here's again just our picture of our block, so make sure your periodic table is colored and labeled like so. Okay, just like I said, the S block really should have helium. Because it has noble gas properties over to the side. So what I would like you to do you see how column 1 was labeled S1 and column 2 is labeled S2? Go ahead and put that at the top of your periodic table just as they are written. Okay, don't put this S2. Okay, what you're going to do is you're going to take helium and you're going to draw a little helium box right above beryllium so that you know that it's part of S2. Okay, transition metals, you're going to start and you're going to put you're going to put D1, D2, D3, all the way across through D10. So starting above SC, put D1 and go across to zinc, ZN, and put D10. Okay, for P block, starting above boron, put P1 and go through P6 above your noble gases. And then your F block, starting above, it's kind of a little off, but you should start with LA and put F1 and go all the way across through F14. Okay, each row or period, okay, is an energy level for S and P. So S and P will show up in almost every energy level except for number 1 energy level only has S, but every other one can hold S and P. And then again, that D orbital is going to fill up our previous energy level. So we're going to start with 3, even though it's on level 4. And then, of course, F is going to start filling up on level 4. And this is kind of what it looks like. Okay. So this is the quantum model, and we're going to need this when we start doing electron configuration, which is our next topic.